Hi guys, today we're going to take a look at page 14 of the Unit 1 classwork packet, and we're going to look at something called angle addition. Now, angle addition is really just the same thing as segment addition, only instead of segments, you're using angles. There's a formal name for this, and we'll go through the formal language. In other words, up here, do you guys see how there's a big angle, angle ABC? And then there are two small angles, angle ABD and angle CBD, okay? So what angle addition formally says, and you might see this in the context of a proof, is angle ABD, or I should say technically the measure of angle ABD, if I want to be really specific, plus the measure of angle CBD equals, what's the name of the big angle? You guessed it, the measure of angle ABC. So that's technically what should be written on that blank line in your classwork packet, if you want to take like a second or two, right? However, guess what? I'm not really going to require you to remember that because this is so easy if you remember it as small plus small equals big. And yes, I used all caps. I wouldn't normally do that in English because it sounds kind of like you're shouting, right? So let's see how that's actually going to apply to a couple of algebra problems. Or in some cases, not even algebra problems, but things that are so easy you can't even believe it, right? So let's start off by taking a look at example number 2. Which example? 2. Okay, so they give me some information there. They tell me that angle DBC is 74. So let's find that out. DBC. So I'm going to label that as 74. And then they tell me that ABC, okay, so the whole thing is 119. And what they're asking me for is for angle ABD. Do I know what it is? Not yet. So if I don't know something, I'm going to call it X. Okay, so I've got a small, and I've got a big. What would you guys think the equation would be that I have to use in order to find my small? So I would say X plus 74, so these two angles together, equal 119. From here, it's actually just a one-step equation. Subtract 74 from both sides, right? So let's make sure. So 9 minus 4 is 5. Okay, nope. So that's going to be what? I think it's 45, if memory serves me correctly, right? 36. So 26. Yeah, we're good. So in this case, sorry, I gotta check my subtraction sometimes. Anyway, so X equals 45 degrees. Now, unfortunately, they're not always going to be that easy, right? So let's take a look at an example that involves algebraic equations. Specifically, let's take a look together at example 3. Oh no, my board is smearing already. This is not good. Oh dear, whatever shall I do? I have to use my spray after this. Digression. Okay, so question number 3. Meh. Sorry, the picture's not great, guys, but it's the best we can do. Okay, so let me do some labeling here. So this is P, Q, that's angle S, and that's R, and let's fill in some expressions. So this right here is 13x plus 4. This is 10x minus 1, and the whole thing was 141. Got it. Okay, so very, very simply, right? What does angle addition say? Angle addition says that small plus small equals big, right? Okay, so I've got two smalls right here, and so what I'm going to do is write an equation. 13x plus 4 plus 10x minus 1 equals 141. As we said earlier this unit, be careful. From Algebra 1, you must remember that you should combine like terms prior to using inverse operations, right? So in this case, 13x and 10x make 23x. Positive 4 minus 1 makes positive 3, okay? So then a little bit of inverse operations here. So what's that gonna give me? 138. And I'm gonna go out, take a wild guess here, and I'm gonna say that x equals 6. Let's see if I'm right. 6 times 20 would be 120, and 6 times 3 is 18. Put them together, and I am good. Okay, so that gives us one of our 3 answers. Now the other 2, they ask us to find angle PQS and angle SQR. In other words, they're asking us to find these 2. So with that being said, I'm gonna have to substitute. Once there, and once here. So let's do this one first, right? So 10 times 6 minus 1, 60 minus 1 is 59. Okay. Over here, I'll show it all the work. So 13 times 6, right? 60, what is that, 78, I think, right? Yeah, okay. And that gives me 82, right? And of course, if I want to check to see if I did this correctly, well, these 2 should add up to 141. And do they? Oh, thank God. Yes, they do. At least I think they do. Yes, they do. Okay? Okay, let's try one more example here. Okay? One more example here, and then in a separate video, we'll go over some kind of like challenge problems. So the last one we're going to do for now is actually on page 15. So if you can look with me at page 15 of the Classwork packet, and we're going to look at number 6. Alrighty, page 16, number, what did I say? 16, page 15, I apologize. Yeah, page 15, number 6. Too many videos in one day. Alright, so let's see what they tell me here. They give me a straight angle. So we got D, E, F, and that's a G, right? Okay. And they tell me that DEG is this, 23x minus 3. Did I read that right? Yeah. And that's 12x plus 8. Okay, so this problem you may have actually seen either in pre-algebra or the year prior, all right? Here's the basic thing. We still have small and small together equal big. The only thing that's different about this problem is realizing, well, how many degrees is the big? How many degrees is a straight angle? Anyone? Oh, 180, right? Of course, that's what you were gonna say. Yes, of course. Okay, so I write an equation. Then I'm gonna make sure that I combine like terms. Remember, a few of you guys have some issues when it comes to combining like terms, right? I lost 3, but I gained 8 back, so I have positive 5. Then subtract 5 from both sides. And I want to show x equals 5 when I do that. Last but not least, if I want to find the measures of DEG and GEF, I would just substitute. I don't know why I drew the arrow right there. Should really be going right there, right? Yeah. So when I plug in 5 here, 115 minus 3 gives me 112. And over here, 12 times 5 is 60 plus 8 equals 68. 112 and 68 together, do they make 180? Yes, they do. So those are the basic problems. In the next video, we're going to take a look at 2 examples of a slightly more complex problem. One similar to what you could see on the EOC, or if you're in honors and watching this video, on your Unit 1 test.